I hope you all enjoy the energy here at Google Cloud Next. Yesterday, we made a major announcement that Spanner Omni is officially in preview. We are bringing Google's databases innovation to your infrastructure. Today, over the next 45 minutes, we'll uncover more details of this new offering. My name is Wenzhe. I'm the Group Product Manager for Spanner, also leading the Spanner Omni. We are very excited to have with us today our distinguished customer, Pablo Arrojo. He is the tech leader from Mercado Libre, the largest fintech, logistic, and e-commerce company in Latin America, presented in over 18 countries worldwide. Also join me today, Chris Taylor, Google Fellow, the founding engineer of Spanner, and also the leading TL for Spanner Omni. We have a very exciting lineup for you today. I will begin by sharing with you the overview of Spanner Omni, followed by Chris, who will take us through the technical details behind the scene. Then Pablo will share Mercado Libre's first-hand journey to Spanner Omni and how they achieve cross-cloud resilience. We will wrap up with a live demo to showcase how to get started with Spanner Omni and also its multi-model capabilities and resilience. We will open the floor for Q&A in the end if time allows. Let's dive in. So over a decade ago, Google pioneered a distributed SQL database market with Spanner. It is built on a distributed scale-out architecture that's similar to NoSQL, with ACID compliance and the strong consistency of a traditional relational database. Over the year, Spanner has evolved into this interoperable multi-model database, incorporating SQL, key value, graph, full-text search, vector search, and the analytical processing with columnar engine, which are all the critical capabilities to simplify and consolidate your workload for the agentic AI era. Our customers often have to navigate a spectrum of IT environment, from on-prem databases to public cloud. Throughout the year, we often hear customers telling us that they really love the Spanner technology. But because today it's only available on Google Cloud, therefore, they couldn't adopt Spanner in a more meaningful way that they wish to. For example, mission-critical workload often require this true resilience, high availability architecture that even extend beyond the edge of cloud. The customer need to demonstrate business continuity in the event of cloud outages, or they need to solve for stress exit. Our customer in regulated industry also need to meet those data sovereignty compliance requirements. That sometimes means they have to still leave a large data estates behind on their private data center that may never come to public cloud. We also have some customers that today they need to run in jurisdictions that either Google Cloud may not support, or they need a multi-regional resilience where maybe Google Cloud today only have one region and they still have to meet all this data sovereignty requirement. Thirdly, whether driven by the business needs or the end customer, many companies adopting this hybrid cloud or multi-cloud strategy. We all know that managing different technology in different environments can be a real nightmare. And in order to minimize the development and the operational complexity, and also you really don't want to minimize your innovation and just optimizing for the lowest common denominator. Last but not least, we also have customers today, they either prefer self-managed on principle, or they're committed to other infrastructure, but they're still very interested in a lot of this differentiated capability of Spanner, such as multi-model capabilities or graph. So we want to provide all these customers a new way to access Spanner. To that end, we are very excited to introduce Spanner Omni, a downloadable software version of Spanner that you can deploy anywhere. We are bringing Google's scale and innovation to your infrastructure needs. Spanner Omni delivers the same core Spanner capabilities with additional deployment flexibility. You can run Spanner from a single server to clusters of thousands of servers. With flexible configuration, either regional, multi-regional, on-premises, multi-cloud, hybrid cloud. You can also deploy in a connected environment or an air-gapped environment. You can run Spanner Omni seamlessly on virtual machines, Linux containers, or Kubernetes clusters. It is currently supported on Google Cloud, other major cloud providers such as AWS, on-premises, or even on your laptop. With this additional deployment flexibility, Spanner opened doors to new use cases. Through our work with early adopters, we observed 3 very popular architecture of how customer is deploying Spanner Omni. Number 1, they use Spanner Omni to achieve hybrid or multi-cloud resilience. So cloud Spanner customer often using Spanner Omni as a secondary DR site that's outside GCP to provide them this cross-cloud resilience. Later on, you will hear more of the story from Mercado Libre on how they are doing that. Customer also can use this cross-cloud HA architecture in jurisdictions where maybe today Google Cloud only have 1 data center. So they can meet the data sovereignty requirement while also achieving multi-regional resilience. Secondly, Spanner Omni really provides this write once, run anywhere application building experiences across environment. It allows customer with multi-cloud strategy or hybrid cloud strategies such as ISVs or SaaS providers to standardize on 1 database technology with the reduced operational overhead and the true application portability. Lastly, Spanner Omni allows customers today who still have substantial on-premises commitment or prefer to self-manage to tap into Spanner's innovative technology to build or rewrite their next generation AI application while achieving the scale assurance, high availability, global consistency, and much more. While Spanner Omni strive for parity with managed Spanner experiences, there are some operational and functional differences to keep in mind. In nature, Spanner Omni is a self-managed software. Customers are responsible for the routine maintenance, version upgrade, or infrastructure monitoring. And also because it is run on customer-managed architecture, so we will not provide availability SLAs as in Google Cloud Spanner. However, you will be able to achieve the same availability if you follow our reference architecture. Spanner Omni is designed to run anywhere. Therefore, to make it truly environment agnostic, we also excluded a lot of this dependence that's relying on Google ecosystem technology. For example, integration with BigQuery, Knowledge Catalog, or Gemini Enterprise Agent Platform. In this preview, we'll also now support the full-text search, enhanced query, which is based on Google proprietary search technology, data boost, or geo-partitioning, some of which we are looking to close the gap down the road. Despite certain feature differences, we are committed to deliver the same industry-leading performance and scalability. So in our repeated benchmark test, Spanner Omni has proved to be able to process millions of queries per second across petabytes of data in single deployment. And it doesn't stop there. With that, I'm going to invite Chris down the stage to talk about more the technical details under the hood.
Hi, thanks, Wenzhe. I want to start off with the basics. So first off, how you get Spanner Omni and how you connect to it. We packaged Spanner Omni as a pre-built Docker container available in Google's Artifact Registry. The container is designed to run in Kubernetes on plain VMs or even on Mac or Windows via Docker Desktop or Podman. For Kubernetes, we also provide a Helm chart for easy setup and management. Spanner Omni supports the same Spanner client libraries you're used to. You'll need to use the newest version of the client, which allows you to point to your Omni deployment and configure Omni-specific security parameters like passwords or client certificates. As of today, we support Java and Go. The full range of Spanner client libraries will come closer to GA. The very simplest form of Omni, as we'll show later in the demo, is just downloading and launching the container and pointing your client at it. You can get started right away. But for now, I want to talk about what a production Spanner Omni deployment looks like and a little bit about how it compares to the Spanner managed service. Like the Spanner managed service, a Spanner Omni deployment is made up of one or more zones, each of which is in the cloud availability zone or data center of your choice. You're free to mix and match across clouds and your own data centers. Each zone stores a full copy of your data, and the zones work together to provide replication and fault tolerance. Within each zone, you can run as many Omni servers as you'd like, as few as one, or as many as hundreds or thousands. Most likely, you'll choose to run these on VMs or in a Kubernetes stateful set. Each server has its own attached block device and should be network reachable from all the other servers in all of the zones. Your clients can connect to any server in the deployment, or more likely, you'd set up a load balancer in front of the servers and point your clients at that. If you use Kubernetes, that's orchestrated by our Helm chart. And really, this is it. There's no additional dependencies to manage. There's no complex time hardware. It's just servers with disks. As you create databases, load data, and start running your application, Spanner will automatically distribute data and workload within each zone and maintain synchronous Paxos replication across the zones. Zones are our key building block. Spanner will continue serving even when bad things are happening in a minority of zones, giving you time and space to triage and repair without any application impact. Next, I'd like to peek inside a zone and see how it's architected. So here's a sample zone with 3 servers. You can have more or fewer, but this worked well with the slide. Your database tables will be divided into small pieces called tablets, and each tablet is served by one of these servers. The server contains 3 sort of logical components. The front end receives gRPC requests from the application via the Spanner client library. The front end routes API requests to the server that's serving the needed tablet. The database portion is the core of the product, and this is really the same code that we run in Google Cloud. It's where transactions, Paxos logic, SQL query processing, and all of that occur. For requests that require multiple tablets to coordinate, the database layer is what does that coordination. And finally, the storage layer interfaces with each server's attached file system, making files available both to the database layer on the same machine and, critically, over the network to other servers in the same zone. This is similar to how we do storage in the cloud, where the layer of interaction between storage and compute allows Spanner Omni to scale and load balance very fast without any slow or expensive data copying. This storage layer is new for Spanner Omni. It provides the database layer the same storage APIs that Spanner uses in Google Production, but sort of adapted for this node local storage, which is important since node local storage is ubiquitous and available in both cloud and on-prem environments. To help organize this storage layer, a few of the servers in each zone are designated root servers, and those help organize the files, organize load balancing and propagation for the rest of the zone. As part of the journey to build Spanner Omni, we actually had to solve quite a number of really fascinating distributed systems problems. This talk is not long enough for all of them, but I wanted to touch on a few of them a little bit, and we'll talk more about them in the coming weeks and months. The first is software true time, which is a new invention. Our inventor is in the audience over here, which provides the consistency, availability, and performance properties of true time, which, if you've been around Spanner before, is one of our critical enabling pieces of technology. But with software true time, we bring none of the hardware complexity. It doesn't depend on synchronized system clocks across data centers or even within the data center. So it's super flexible and compatible with the sort of heterogeneous environments where we expect to run Spanner Omni. Spanner Omni also provides backup and restore to and from object storage, which gives you an additional layer of disaster insurance that doesn't require any external synchronization. The Spanner deployment will sort of manage taking the backups, manage restoring them. And with this sort of snapshot of what you're looking at, I want to pass the mic to Pablo. who will tell us about the successful Spanner Omni deployment at Mercado Libre.
Thanks, Chris. Hi, everybody. I'm Pablo. I'm technical leader at Mercado Libre. And today I will show you how I'm using Spanner Omni to achieve multi-cloud capabilities for data. First, a brief introduction about Mercado Libre. We are the largest e-commerce, fintech, and logistics company in Latin America. Our operation extends across 18 countries, engaging over 80 million unique active users. Currently, our team includes more than 100,000 employees. In our marketplace, we have around 700 million eat and sold per quarter. And with the marketplace and outside, our financial ecosystem is processing 4.5 billion payments per quarter. Such a large-scale business needs equally large-scale technology. Our mission and new SQL service is to deliver high-performance, impactful distributed databases to our more than 20,000 developers. We choose Spanner as a backend because its great capabilities like unlimited scale, sync replication across zone and region, providing SQL interface and guarantee a strong consistency. Today, at peak of traffic, we are scaling over 700 nodes, including regional and multi-regional configuration, and we are handling around 500,000 requests per second. These are some of the most important use cases powered by Spanner. For example, recommendations team is using combining OLTP and vector search to deliver user recommendation, ads personalization, and flash sales. Create limit service is storing and processing payments. User identifier uses Spanner to store user accounts for account identification core functionality. And we are powering AI agents, serving as a conversation store for both financial and marketplace AI assistants. All these services are really critical for a business, and we need to ensure a high level of protection for the data involved. Our data must fulfill three fundamental capabilities: multi-project, multi-region, and multi-cloud. With the Spanner in GCP, we can cover the first two. Spanner offers multi-region instance configuration, and we achieve multi-project capabilities, copying Spanner backup across different GCP projects. However, we still need to cover multi-cloud, something that Spanner today doesn't solve. In this context, design and build a multi-cloud solution presents several challenges. We need a database able to run outside of GCP with similar scale capabilities to Spanner. We must handle compatibility constraints, for example, different kind of consistency level, concurrency control mechanisms, unsupported data types. Also, we need to achieve expertise and knowledge in a new technology. With Spanner Omni, all these challenges practically disappear for us, so let's explore how we are implementing a multi-cloud solution. We are working on two approaches when we are replicating data from Spanner in GCP to Spanner Omni in a different cloud. As Wenzhe already mentioned it, Spanner Omni offers great flexibility. You can run it anywhere with different kind of configuration. We have tested running on both Kubernetes and VMs. Finally, we decided to use VMs by deployment to be aligned with other database services on Mercado Libre and a faster go-live in production. Our first approach goal is replicate data for data protection cross-cloud. We are using a zonal deployment. This configuration offers scale-out capabilities and a reduced cost infrastructure. All Spanner Omni servers run in a single zone, starting with a root server, which contains deployment metadata. And we can scale horizontally, adding non-root server to our deployment. By the other hand, as a trade-off, this configuration doesn't offer high availability as the data is distributed across Spanner Omni server, but is not replicated. For our second strategy, in addition to data protection, we want to ensure service continuity in case of a GCP outage, switching application traffic to Spanner Omni. We are designing this solution using a regional deployment. This is a robust configuration offering both scale-out capabilities. We start with at least one root server for each zone, and we can add non-root server to scale out horizontally. And high availability capabilities as the data is replicated across 3 availability zones in a single region. How are we replicating the data? We work with a two-phase procedure. First, we run an initial load with an export-import strategy. We export data from Spanner in GCP to a bucket in cloud storage in CSV format. And then we load the data into Spanner Omni using a custom data flow template created by our team. Once the initial load finished, we enable a near real-time replication job. Again, we are using a custom data flow template. And this job reads a Spanner change tree source, extracting all data changes, insert, update, and delete, apply transformations in a 1-second size window, and then apply all mutation to Spanner Omni in parallel fashion. We decided to use data flow because provide great capabilities like horizontal scaling, offer Windows ordering when reading data from change tree in source, and provide building metrics like replication lag. With this strategy, we keep both databases in GCP and different cloud with Spanner Omni with a lag of just a few seconds. Okay, let's continue with observability and how we are monitoring our deployments to analyze and debug performance issues. Every Spanner Omni server exports metrics by default through port 15012. We are using Prometheus to collect and store these metrics. And then with Grafana, we create dashboards to visualize this data and set up different kinds of monitors and alerts. This is a reduced picture of one of the data Grafana dashboard. Spanner Omni provides a lot of useful metrics, either from infrastructure like CPU and storage usage, from the database like number of requests, throughput, latency, logs. We are able to create a deep insightful dashboard, pretty similar to those available in GCP for Cloud Spanner. Okay, I covered the infrastructure and how we are replicating the data. Let's see our failover mechanisms. Basically, if we want to recover data from Spanner Omni, all we have to do is the inverse of the data replication. We already create a data flow template to export data from Spanner Omni to a cloud storage. And then we can use Google provide data flow templates to load this data again to Cloud Spanner in GCP. To those scenarios when we have switched application traffic to Spanner Omni because GCP outage, once the source database is already available, we can switch our replication job to extract changes from Spanner Omni and start to replicate to Spanner in GCP to synchronize both databases and switch back our traffic to GCP. Earlier, I mentioned some of the multi-cloud challenges. This is a simple snippet which I think highlight how Spanner Omni solves these challenges, specifically for compatibility know-how. If you want to switch our application to run with the Spanner Omni, all we have to do is modify the way we create our database client to connect to the database. We don't need to change any other line of code, dependencies, or SQL syntax. Both databases both technology has a great level of compatibility. Finally, where we are today, we are already replicating more than 10 terabytes of data to a Spanner Omni. Our replicator is replicating with a throughput of more than 10,000 TPS. And we have an infrastructure of around 200 vCPU. Thank you. Now, Chris.
So thank you, Pablo. This was really inspiring to see. I was just telling Wenzhe, it's amazing when a plan comes together. And this was the sort of thing that we were hoping people would be able to do. So next, we're going to dive into Spanner Omni with a live demo God's willing. So we're going to start small with a local single server deployment on a Mac laptop using the Developer Edition. To show you how easy it is to get set up and running while exploring Spanner's powerful multi-model capabilities. Later, we'll move to a scale-out Kubernetes deployment and showcase Spanner's resilience. As we mentioned, the Omni Developer Edition container image is available for download in the Google Artifact Registry. We'll provide a QR code at the end of the talk. The Developer Edition is perfect for tire kicking and local testing and is free. Developer Edition databases work for 90 days, during which you can explore the core engine, test at scale. There are some enterprise features like advanced authentication, encryption, backup restore that we reserve for the commercial edition. If you do want early access to the commercial edition during the preview with full features, please visit our website or reach out to your sales team, and they can help you with that. So now we're ready for our demo. You can, as we've said, deploy the Omni container in your own server, VMs, Kubernetes. Here, we're keeping it simple. We're running on a laptop. This is a Mac laptop on the stage in single server deployment mode. So our container image includes the database engine, CLI for controlling the deployment, and a UI console. The CLI is also available as a standalone download that you can run on most platforms with no container at all. That's what we're going to be using for parts of this demo. And we want to kick off now by starting a server container. We're using Podman for this demo. You could use Docker with very similar commands. You can sort of see our artifact registry path here. We've mapped 2 critical ports, port 15,000, which is for client connections and CLI access, and 15,026, which is where the Spanner UI console will run. So let's check the status, make sure this thing is running. It is already running. It takes a couple of seconds for the most part. And we're ready to start using our new server. To make it easier for you to get started, the CLI actually includes a sample data set, which we also use with Cloud Spanner. You can load it with one very simple command. It's built into the Omni command line. And we can do that now. And the whole process of loading it really just happens that fast. The sample database simulates an e-commerce platform. It features 7 tables covering users, product catalog, orders, payments, a couple of others. The schema also includes a simple e-commerce graph, which doesn't need a separate load because it's a seamless view over the tables we did load. And so we'd like to start running queries, but first we're going to have a look at the UI console. The command that just ran runs the console in the same container as the database. That's for simplicity of demo. In Kubernetes, you'd probably run it in a different pod. We're going to look at the console now, see our server hopefully show up. It takes a few seconds. And are we going to get something here? Maybe. There we go. All right, so we have a healthy server. We can look over at the databases tab now and see this retail DB that we just created. This is the quick whetting your appetite on the UI. We're going to switch back to the command line and show you how to see the database list on the command line as well. Just a moment while we switch. Here we are. So we're going to look at the databases again on the command line. So there's 2 databases here. The retail database we created earlier, and a built-in monitoring database that the console is using for its statistics and graphs. You can actually query the monitoring database directly if you want to get similar information. So let's open an interactive SQL shell, and we'll run a few sample queries, starting with show tables, so we can see what we're doing here. And you can see the 7 tables in the sample database. And where I want to start out is with a typical relational SQL query to answer the question, what was the best-selling product category in 2023? You can see we've pasted it here, and we're going to run it. So we're joining the product catalog table with the orders table, sorting by total revenue, pretty standard stuff. Let's see where we're at here. Oh, we're working on copy-paste. Give us a moment. Hit enter. Or actually probably at a semicolon and enter. Okay, now you can paste again. All right, we're back in business, thank you. Okay, so here we are. So we've got our product categories, their total revenue. Our little store sells a lot of electronics. And so we're going to poke around and see what kinds of queries we might use to make our storefront work. So we're going to simulate a typical customer request to look for a phone. We're using full text search on the product table's description field. This way, even if the product name doesn't contain phone, we can still find it, return it to the user. So we've executed the query here. We found 13 products with ID, name, description, price, sorted low to high. On this list, the Smith Allen mobile phone catches the eye because it's expensive. So we're going to find out who's buying it and think about a marketing campaign. So in this last query, we want to demonstrate some multi-model interoperability by using graph and vector search in tandem. We're going to start with the product ID of the Smith Allen mobile phone. But instead of limiting ourselves to that single item, we're going to use vector search and identify a cluster of contextually similar products. We're passing that expanded set to our graph query engine to find customers with shared purchase histories. And this is allowing us to move from targeting a single product to targeting a lifestyle or preference group. And this should help us expand the reach of this little marketing push. So we have a good list for our email campaign, and we're off to a great start. So that's a few queries to sort of whet your appetite for Spanner. In our documentation, you can find a lot more sample queries to try. But for now, let's get back to Omni and have a look at more of our UI console. So we're back in the console we saw earlier, where we looked at server health and saw the list of databases. Now we're checking the Insights tabs. On the System Insights tab, you can see CPU utilization, request latency, similar information. Query Insights is going to allow us to see expensive queries and some more, and I think sometimes that takes a little while because we've just run these queries. Here we go. Yeah, so you can see some of our sample queries running here. So that's our laptop experience. You can sort of see it got started quickly. You can try out our sample application. You can load data from one of your applications. Now that we've whet your appetite for the laptop experience, we're going to move over and use a real Kubernetes cluster running on AWS. So we've already set up a deployment across 3 AWS availability zones. They're all running on EKS. The shell Wenzhe just opened has credentials already loaded for the Kubernetes cluster. We've put port forwarding in place so that she can run CLI commands against the Spanner deployment from her developer machine. So we're going to start by looking at the zones and just kind of getting a sense of what this deployment looks like. So each of these zones actually has 5 servers. 3 of them are root servers, which have a special role in supporting the zone. So we show them in this list zones command. And a zone will be able to serve as long as a majority of its root servers are healthy. But now let's take a closer look at one of the zones in particular. So you can see all 5 servers now, the 3 root servers listed first and the 2 non-root servers. In larger zones, you'd probably have many more non-root servers. This is the primary mechanism by which you scale. Now let's take a look at this same deployment in the monitoring. As Pablo mentioned, Spanner Omni exports Prometheus metrics. And for larger deployments, it's really easier to visualize the zone through our Grafana templates. We've provided some, as Pablo showed, you can make your own and get it to really look the way you want it to. Before the demo, we loaded a 1 terabyte YCSB data set, and we have a YCSB client already running to generate load for this deployment. And as you can kind of see, there's some load on each of these servers. We also set up a dashboard for this demo to just give you a clearer view of the workload. This is YCSB workload B, which means 95% strongly consistent reads, 5% writes, each a kilobyte in size. And we're using the open source YCSB driver, pretty much stock, with the latest Spanner Java client. YCSB is structured as a bunch of threads, each of which just issues reads and writes in series. For this demo, we're tracking each zone's CPU utilization at the top, and delivered QPS and latency for reads and writes. And now, our goal is to simulate a zonal disaster. So Wenzhe has just scaled one zone, zone A, which we looked at earlier, to 0 pods. And this should leave the data on the volumes, but shut down all the Spanner servers, making the zone unreachable for all of the other zones and for clients. For demo purposes, we used kubectl to do the scaling. The command's short, it's easy to read. Spanner provides Helm charts that we would really recommend for normal administration. So we're watching the pods terminate. We'll give ourselves a moment while the number of them goes down to 0. And there we go. So we can switch back over to the monitoring and see what happened. So what we expect is that as zone A disappears, and the monitoring will take a moment to sort of show it to us, Actually, I think you can already see it, right? So the green line on the top is zone A. You can see how it cut off. That's because our monitoring stopped getting data for it. And so as it disappeared, you can see the other zones sort of quickly pick up the slack. You can see the CPU utilization change in each of the zones. This is Spanner's Omni's built-in resilience, ensuring zero downtime by moving the traffic. So when we removed the pods, two things happened. First, the ongoing reads and writes from our client shifted away from the now stopped servers and onto the remaining ones. Second, writes stopped being able to replicate to the down zone. Paxos is designed to ensure that the remaining zones continue functioning, even with this type of disruption. You can see the write latency go up a little bit, and that's because we really only have 2 zones available to form our quorum. We're not getting the faster of the 2. And Paxos is designed to ensure that the zones continue functioning even with this kind of disruption. And clients are more or less oblivious to all of this happening. Their reads and writes are still seeing the same consistency. There's an interesting artifact that you'll see here, which happens sometimes when we run it, which is that one of the zones we took down was a little further away from the client. And so its P50 latency is actually a little better with more of its requests served in its nearby zone. And because YCSB is doing requests in serial, it actually is sending a little higher throughput through this simulated outage. OK, so now that we've seen this outage and we've seen what the resilience looked like, we're going to try bringing Zone A back to its original 5 pods. This does take a couple of minutes while the pods launch and boot, sometimes a few more minutes for traffic to move back. So we'll see whether we actually end up seeing it during the time of the demo. But while we wait, let's talk about what happens during that time. So as we bring the span servers back up, they'll reattach their old volumes and rejoin the deployment. As the servers boot and storage files become available again, tablets will load. They'll resume participation in Paxos. They'll fetch the writes they missed from the Paxos leader and begin serving reads as soon as they catch up. So restoring redundancy and getting back to continuing with strong consistency. So again, all of this is happening transparently. The client's continuing to issue reads and writes throughout. It's seeing the same strong consistency. From an application perspective, this is just about a non-event. And as the operator of the system, Wenzhe didn't have to do anything to recover either. There was no sort of secret command to switch zones or redirect clients, which this just all worked. We did note that the throughput changed a little bit because YCSB runs its requests one after another. Relatively small changes in latency do change the throughput that YCSB drives. In a real workload driven by end user requests, you would probably not see that throughput change. It's just an artifact of the benchmark that we're running.
It's back.
And it is back. Wow, that's pretty good. We did a run an hour ago, and it took 3 extra minutes, and I was not sure what I was going to say, so this is perfect. So while we continue to watch the recovery behind me, let me recap what we've seen. So Spanner Omni is easy to get started with. We went from a container pull to a running database in really less than a minute. We showed the power of multi-model. Spanner and Spanner Omni combine relational graph, full text search, and vector search in a single engine, along with a columnar engine and powerful analytics. And finally, we showed resilience. We simulated a significant outage and showed Spanner continue with little disruption. We believe Spanner Omni can help you do new things with Spanner, whether that's meeting stressed exit and data residency requirements, serving your customers in multiple clouds, or something else. Since our zone is back, that concludes the demo, and we can switch back over to the slide deck for a few more things. So this is only one of many Spanner talks. We've launched a number of other things at Next. I encourage you to check out any of these breakout sessions to learn more. And your feedback on this session is greatly appreciated. You can complete the survey in the mobile app. And as promised, we have the QR codes to find the demo that we did today, to download the container and use it yourself. Thank you all for coming. We're really excited to see how Spanner can help your businesses outside Google Cloud, and we'll explore that new frontier together. And thank you again.